Can't believe you are back to watch another one of these short videos of me fumbling around with the Monome Teletype, but here we are. I have 3 sounds set up here. Let's just trigger them one by one. First, it's kind of like a snare drum sound from the Afterlater Audio PIQUE. And then got a pulse width modulation. It's a really nice little analog sound from that module. And then finally from the Plonk, got this little metallic drum sound. If I change the parameters here, it comes really, right? Really interesting. So my thought was that I want to do a little patch here where it's relatively simple what it's actually doing tonality-wise, harmonic-wise. What I want to do is make something where I can change the complexity of the rhythms, or maybe not the complexity, but the density of it. And so my thought was that I wanted to use the input parameter on the teletype as kind of a dial turning one direction, and I get less density, turn the other direction, and I get more. And so my idea for how to do that was to use the Euclidean rhythm operator in Teletype. If you're not familiar with Euclidean rhythms, would probably take too long for me to give a full explanation of it here, but essentially it's a function that takes a number of steps, and then you decide how many of those steps should have a hit on it, and then the algorithm decides which one of the steps it's going to fill something in on. In the Teletype, there's an operator called ER. It takes 3 arguments. First is fill, the second is length, and the last is an index. If we set the fill to 12 and we set the length to 12, then we would get a hit on every step. And we advance the steps by changing the index value. If we set the fill to 0, we would get no hits at all. If we set it to 6, we get a hit on every other step. And so that's maybe not that interesting in itself. Where it becomes really interesting is what happens when the steps and the hits don't exactly fit. So when the fill value is not something that's a multiply that you can multiply into the actual length. So for example, if you have fill of 5 and a length of 12, then you gotta find some way to put those hits where you still get all the hits, but you're not gonna be able to put them with the same distance between each of them. And that's where the Euclidean rhythm algorithm puts them in places that are really interesting from a rhythm perspective. I highly recommend you go read more about it or watch some YouTube videos if you haven't looked into it yet. It's really interesting and a really great source of inspiration in my music. Alright, so let's try to do something with this. Let's turn the metronome on first. And then let's go into the metronome, and then at first we can just test things out here. Just fire off a pulse through each of these on every step. Alright. Overwhelming, but it works. So let's instead throw each of these into a separate script. This makes it really easy to work with. Oops. I'll check my spelling here. So now we're still having the metronome hit this script, but every time it's going to hit these. So if I threw this into this script, we would now have exactly the same. So let's utilize that to just quickly test the Euclidean rhythm operator and just hear for ourselves how it works. So we will put the value that we get from the operator, which is going to be 0 or 1. 1 for a hit and 0 for no hit. And then let's do the, what was it I said? What's my sample? So fill of 5, length of 12, and then we'll use the variable called O on Teletype. What O does is that every single time we ask for it, it auto increments by 1, which means that it'll walk through this pattern continuously. So let's try this, and then gotta put an if here. So if j set it to 0, get nothing. If we set it to 12, we should get 1 on every single step. Set it to something in between here, 3. Pretty neat, right? So we have a few problems to solve here. The first is that the O variable, like I said, every single time we fetch it, it increments by 1. And the O variable is shared between all the scripts. So if I just call it within every script, then we're not really going to get the rhythm build-up we want, because each script is going to take just its own part of the pattern, but none of the scripts are going to get the whole Euclidean pattern, if that makes sense. So instead, we're going to make sure that each of them share what we get from O. And so the way I'm going to do that is we're going to use X instead. And X is another shared variable between all the scripts. And so this means that if we hop back out here to the metronome, we can now set X to O. So this means that once at every step, every single time the metronome hits, we're going to set X to the value of it, and then we're going to share that value between all of them. So going back here now, we set this to, say, 6. Awesome. Let me turn the as delicious as the Mimeophone sound. Let's turn it off a second just so we can hear this a bit more. Let's crank it up to maybe 9. So now you can really hear how it's actually creating a complex rhythm. So okay, now we have that step. The next thing we gotta do is, my whole plan was that I wanted to use the rotary knob here for input. And the way we do that in the teletype is it's an operator called param. So if we call param, oh, I see I've already said it. So if we call param, we get the current value of it. It's 10 there, 19 there, turn it all the way down, I should get a 0. So you can configure what you want it to be between. So you can say that you want your param to be between 0 and 10, or 0 and 100, or whatever you want. To make things simple here, I am going to set param to be between 0 and 32, and then I'm going to run each of the different Euclidean rhythms in 32 steps. In that way, I can use param specifically to say how much do I want filled. And the way we say what we want the range of param to be is we use the operator param.scale. So I'll set it to 0, 32. And so if I pull it out now, it's at 0. If I turn it all the way, I get 32. Excellent. So let's go in now and use that in the script. So first of all, let's set the length to 32. And then we'll use param here. And remember, we had it dialed all the way over, so we should get a hit every time. But now when I turn it down, we turn it even further down, Awesome. Turn it a little bit up, maybe. Perfect. So now we just gotta go do the same to the other two scripts, and then we should be good. So set the fill to perm, set the length to 32, and we use X as our index. And then if J, let's turn this down while I'm writing this. J, T_pulse 3. By the way, the reason why I can just say if J is that in the teletype, Boolean value of true or false is 0 or 1. So the return we get from ER is also 0 or 1 for whether there's a hit or none. So it just works out that we can immediately just use that straight ahead as that. So now in theory, script 2 should be adding the second voice to this. So if we turn up fill again here. Awesome. You see those two in parallel. Turn it down a bit. Yeah, let's go to the next. And all right. A bit of Mimeophone again here. So that's pretty awesome. However, it does sound a bit boring because all my three sounds are each triggered on exactly the same step. So my thought is that what we really just have to do is we just have to offset them a little bit. That would be one way to make it a little bit more interesting. And so all we gotta do here is add something to X. So this one, say, it's 3 steps out. And this one will have it 10 steps out. So this is not gonna be perfect. And there's going to be some issues with this wrapping, because I do believe that our O value wraps between 0 and 64 as default. So this might be a little glitchy, but it should kind of show us what we are thinking about. So let me try turning it up again here. So that gets a little bit of what I wanted. It doesn't fully capture it, and I think the reason for this is that they're all running at exactly the same fill. So let's try to adjust that. Say like the drum here, plonk sound. Maybe we could use less of that. And so let's divide the fill by 3. again. Turn all the way up. Alright. So that's definitely better, but I think we can make it even more interesting. Let's take the bass sound here off as well. Let's maybe divide the fill by 2 here. So now the snare is really the only one that's with like really high fill. So if we go all the way up, we should have snare on every hit. You know what, now that we're doing this, I probably don't need to do the offset anymore. So let's try to remove that and see what that sounds like. That's pretty awesome. Alright, I'm pretty happy with that. My next step in this would probably be to start using the scale tools that I posted another video about, to create a little bit of a chord progression, or at least some melodic lines within the scale. And I believe that the Plonk sound here is actually tuned, so that should work between both the pulse wave and the Plonk. But this video is probably already too long, so I'm gonna continue this in another video. Turn off the metronome. Alright man, thanks for watching. As always, if you enjoyed this, leave me a comment on what you would like to see next, and click like and subscribe, and look forward to having you join in again the next time. Thanks.